We just saw how Jackson the Thief was defeated by our model. Before we get to the technicalities, here is a quick introduction. Our Capstone project titled Multimodal Authentication System was developed by CPG-105, which includes Sahil Ahuja, Saket Sinha, Sakshi Dhodra, and Vikas Dhiman of BE Final Year COE, Thapar University, Patiala. Special thanks to my sister Tanya Ahuja for playing the role of Jackson the Thief. Our project has been designed keeping in mind that it should be reliable and easy to use. It must provide 4 authentication methods and authenticate in general with all hardware and software clients. We have already seen how useful the multimodal authentication system is. Let us have an in-depth understanding of its components and their functioning. This is the block diagram representing architecture of the project. 2 blocks in the upper half represent the data acquisition and the server unit, while the 4 blocks in the lower half include sensor grid, LCD module, face recognition module, and the Android application, which acts as an interface to the user. Let us now have a quick glance at the electronics under the hood. On powering the system, the LCD module shows an initialization message. Both Raspberry Pi server and Arduino based data acquisition unit boot up and takes a few seconds. Finally, we see the interface menu on the LCD module. The Android app provides real-time status of the state of all the sensors and whether access is granted or not. It also has a live logs feed which tells when the request for access was made. The Android app can be connected to multiple AUTH systems through their IP addresses. The demo here shows how in real time the sensor status changes from N, which represents no, to Y, which represents yes. Initially, status of all the modes are set to N. On pressing 0, we enter the keypad mode and then enter the pin, which is 1, 2, 3, 4 through keypad. The status of keypad mode changes to Y on successful authentication, which is reflected in both the LCD module and the Android app. On pressing 1, we enter the RFID mode. On swiping the RFID key, its status also changes to Y. Now we move to fingerprint module by pressing 2. Since my fingerprint is already registered on the system, its status also updates to Y. Since 3 modes have been satisfied and the level is 3, the grant changes from N to Y. If the level was 2, then we were supposed to pass any 2 of the modes. Also, we can see that the logs have been updated. The servo also rotated when the grant was set to Y, but it was too fast to be captured. Now we move on to the face recognition module by pressing 3. Finally, its status also changed to Y since my face was already registered and was reflected in the LCD module. We can also get live video stream to invigilate remotely. To get the live video feed, open your browser and write the socket address. This can be used as a surveillance tool and thereby improve security. The Raspberry Pi server serves both the video feed and the API data, which is used by the Android app. APIs are a very powerful way of integrating with software. In this demo, Servo was a hardware client. Now let's try with some software clients. Yeah, you are right. The app was also a software client, but let's try it with the website now. Let's reset all the modes and try authenticating it again for the website. This is a simple website for managing a hotel. Instead of using the normal login form, we are using the Multimodal Authentication System login. Initially, the website fails to log in since the Multimodal Authentication System has not authenticated it. Since the level set is 3, we have to pass at least 3 modes. Once all the 3 modes are satisfied, we again try logging in. Also, for security purpose, the system resets itself after every 10 minutes. We see now that the system has logged in successfully and the website has been authenticated. And we can easily check out from the hotel or order some food. Now let us assume that somebody cracked the system by chance. What should we do now? You can get his image, since AUTH clicks images every 5 tries. Open your browser and type the socket address /download to get all the images. You can get a zipped images folder which contains all the images that the system has recorded when some trial has been attempted. Now we have explored the normal mode. Let's move on to the master mode. In the master mode, we can add or register new users. You can also edit password, add new fingerprint, RFID key and face using this mode. You can move from normal mode to master mode using secret token. So keep it very secure. The set of keys that have special meaning to the authentication system are ABCD for switching between modes, DCBA for restarting both Pi and Arduino, ACBD for enabling level 2 and DBCA for enabling level 3. Also, *# can be used to reset just Arduino. These codes are hard-coded and therefore needs to be kept secure. This is a quick demo of all the codes that I have just pointed out. Keep an eye on both the LCD as well as the keypad. The code ABCD has been used to enter into master mode and a new password has been registered. If we again press ABCD, then we can come back to the normal mode. To change the level of the security, we can use ACBD code and set the level to 2. The code DCBA is used to restart both the Pi and the Arduino. Feel free to go back and see all the codes in order to get a better understanding of the demo. These codes are just like the opcodes that we have in microprocessors and helps us to add or delete new users and also to change the level of the system. The level of the system decides the level of security and can be changed according to the situation. In households, we would prefer the level of 2, while in case of firms and banks, we would prefer to have a level of 3. The system automatically resets itself after every 10 minutes, but if we want to manually reset the system, we can just do so by using the codes, which is *###. With this, we end the basic demo of the multimodal authentication system, which forms the Capstone project of our group. And due to lack of disposable resources in this lockdown period, we couldn't get a good video shot, but still we have put in our best and tried to cover all aspects of the project. Let's now look at the final packaged project that we have made. The keypad works just fine as we saw, and also it integrates well with the application. Now let's try the RFID by swiping the RFID key. It also works fine. Both keypad and RFID status have changed to Y. Now let's move on to the fingerprint module, and it also works perfectly fine since its status changed from N to Y. Let's have a closer look at the app, and it also looks perfectly fine. Finally, we have a look at the different views of the project. This project has been a great learning experience for us. Thanks for watching.